Alright, so right now we're solving the trigonometric identity of 2 sine x cosine x plus sine x minus cosine x squared over secant is equal to cosine x. So this is a complex trig identity, but we're just going to break it down and we'll make it simpler to solve. So right here, we're going to take this part of 2 sine x cosine x, and following this identity, you have to think of it as like 2xy is equal to xy plus xy. Because you're looking at xy and you're multiplying that by 2. So xy and another xy. So you think of it as a sine x and cosine x plus another sine x cosine x. So if we take a couple manipulatives, say sine and cosine because they're multiplying, and then adding another sine and cosine, we then have this first part. So then we're going to look at this part of sine x minus cosine x squared, and if you look at it, it's actually a difference of squares formula, and we know that it would then look like sine x squared. So we put in for our addition, and I'm going to bring it down right here so we can stay within the camera. We have sine x, or sine squared theta minus, and we're getting in another sine times cosine, so we're going to have another 2 sine cosine. So we're going to have minus sine cosine minus sine cosine, and then finally adding another cosine. So now that we've expanded the top line of it, the numerator, we're going to notice that we have a sine minus, so now looking at our second line of equation, we see that we have a sine squared theta right here and a cosine squared theta right here. And these have nothing to do with these, so we're just going to bring these down to another line, and we're going to see sine squared theta plus cosine squared theta. Well, we know because of Pythagorean identities that sine squared theta plus cosine squared theta is equal to 1. So now we've simplified this part to just 1. So now that we have the 1 right here, we can look at this, and it's already kind of lined up, but if we just add a little bit more of a line to it, then we see that these two are negatives, so this will actually cancel out the complete top line of it. So now all we're left with on the top line is 1. And then if we bring back into our original equation, secant of theta, well, we know that secant of theta is actually equal to 1 over cosine. So now what we're looking at, so now we have 1 over cosine. And we know that if you have a fraction over a fraction, you sing the little song, division of fractions is easy as pie, you flip the second one over and multiply. So what we're going to do is flip this fraction to cosine over 1, or just cosine, and now we have 1 cosine. Well, now we can introduce the right side of our equation again, equals cosine. And remember, anytime there's a 1 in front of our variable, or in this case cosine, the 1 just kind of cancels out, and we have now cosine equals cosine, and our trigonometric identity is now proved, and this is a true identity.